My name is Tao Xin from JAST. I would like to presentation about design of a data auto-select system using data catalog for smart home. This is the outline of this presentation. Now, device maker provides service to their device. With the popularization of smart home, service need to be improved. Because this, the way to provide smart home service will change from closed to open. So third-party service provider will be available. In the new way of providing service, how service developers find data from device maker is not clear. To unify the data description, JETA proposed the JETA Smart Home Data Catalog. It was able to standardization the data description in data training. So what is the data catalog? It's a format to summarize information of data, such as location and details. There are three ways to get data from device maker. The first one is get data from standalone cloud. Every device maker has a cloud for data training, so service developer should access the cloud directly to discover and select data. The second one is using market platform. Market platforms store data and device metadata. Device makers setting their device send data to the platform and register the device to the platform. So service developer can discover and get data from several device makers by using the market platform. The second one is using data catalog and the data exchange platform. Data exchange platform just store the metadata. Service developer can get information about data from the platform and get data from device maker in many ways. In order to unify the data description, JETA proposed the JETA Smart Home Data Catalog. This data catalog has three parts. The body part is about data's owner, data's delivery, information modified date. The detail part is about what device generates this data and what this data observed for. In usage part, there are some requests from provider, such as payment and license. JETA Smart Home Data Catalog designed to read by person, so it's almost write in free text, and designed to use by free word search with category and show the result as a table by the web browser. So for now, there are some problems in discover data. The first one is when service developer search and select data. The number of search results will over the number that people can read and select. So they need a method to select without human operate. The second one is when new data is available. If service developer want to find the new data, they just can search and select one more time. So they need some can support the discover without human operate. The third one is data description cannot search accurately. The result of free word search may return some wrong result, so they need a method to return accurate result. To solve these problems, we propose a system to make service developer discover data quickly and easily. As a result, promote data training and support the creation and improvement of service. In this figure, the auto-select system is a proposed system. This system uses data catalog and based on data exchange platform, so the mechanism of data delivery not in the proposed system. The data auto-select system uses JETA Smart Home Data Catalog and just store data's metadata. It has a human-readable interface, so it can provide a graphic interface for people to read, and have a machine-readable interface, so it can provide an application programming interface for user software to get information, and have an auto-select function, so it can select search result automatically and without human operate. The auto-select system has 4 parts. The first one is data catalog for machine readable. To make the Jita Smart Home data catalog from human readable to machine readable, we change the part to classes, item to properties, and declare the relationship between classes, define data type from free text to specific, and standardizes the property about data type. So after modify, it can be searched by a semantic method using Sparkle and return accurate results. The second part in proposed system is data auto-select method. The data auto-select method based on a ranking method called CPWI. It uses normalized parameter and compute the algorithm distance with weight. The parameter is a property of target that defined by a number, and the smaller value of CPWI is similar to the user's ideal target. In this formula, W is parameter's weight. Is set by system user. U is parameter's ideal value and is also set by users. S is target's parameter value, and UD is a default ideal value used when U is not setting, and N is number of parameters, and I is current number of parameters. But there are problems by using CPWI for auto-select. If one parameter is set with a big weight, and this parameter is very similar to ideal value, other parameter will be ignored. So in auto-select, it will bring about a wrong result and return to user. To solve this problem, we make CPWI with parameters bounds. Like the lower figure, the red line is parameters bounds. Because SA is over bound, it will not be a result and compute in CPWI. The third part of proposed system is needs description model for auto-select. We define a flexible and machine-readable needs description model as a base model to describe users' needs. This model has 2 parts. The request part is used for search. It has some property name and value, and a logical expression. The logical expression is used for describe the relationship between the properties. It uses any of, all of, not that defined in JSON schema. It makes the logical expression can serialize it to JSON. The option part is for auto-select. It has ideal value, weight, and value bounds. The final part of proposed system is interface. System has 2 interfaces. The machine-readable interface is a REST API and use post method. User can post needs that write in needs description model and serialization to JSON for setting search and select condition. It will return the most similar data information in JSON. The human-readable interface is a web page. By this interface, user can select property or parameter and make the logical expression. It will show result ordered by CPWI value in ascending by table. The data auto-select system is implementation in Python and use package Flask. And it has 5 parts: process part, record part, machine-readable interface, and human-readable interface, and provider special interface. The process part converts the needs description model to Sparkle, search data catalog, auto-select search results, and write the select result to process result record. The record part uses CKey and MongoDB, sort data catalog, and auto-select result. Machine-readable interface and human-readable interface based on same function and The difference is the number of results. When using human readable interface, it can be set. The provider special interface is used for upload the data catalog. Device maker can upload the metadata by this interface. And we combine the auto-select method resource model to the needs description model. The request part is no change, but the property name should be selected from resource model. In option part, we add the selectable parameter from resource model. Every property that can be written in a number can be used for auto-select. In this time, we just use accurate, update frequency, and price. In experiment, we did some preparation works. First is create a data catalog with iHost device and replace parameter to some special string on this catalog. Make the data catalog to catalog data template file, and then use this template file with some different parameter to generate 10,000 dataset information and upload to data auto-select system. The scenario is metadata generation script generate information continuous and upload to data auto-select system, and the data obtainment script send the needs to data auto-select system's machine-readable interface and get result. Record process time cost and the number of results. By the experiment, we get some result. The upper figure is about result number. The green point shows the number of datasets in data catalog, and the blue point shows the number of results will not use the auto-select, and the orange point shows the number of results that return to the data info obtainment script. The lower figure compared time costs about human select and auto-select. Blue shows select by human. Because we cannot find the real person to read many thousand results, so we define the read speed is 0.3 seconds per result and can get same result with auto-select. It uses left axis. Blue shows select by human. Because we cannot find a real person to read thousand, by this result we can know with the same number of results, a lot of time can be saved by using this auto-select system. In this research, we proposed and implemented a data auto-select system for smart home data exchange. The Jita Smart Home Data Catalog is implemented as a machine-readable resource model in this system. A ranking method used in proposed system with value bounds for auto-select. This system has a machine-readable interface. By this interface, user can get information automatically by using software. We proposed and implemented a needs description model for describe users' needs in this system. Through the experiment, this system can make up the shortcoming of manual selection and support data exchange. As the future works, we would like to figure out about when service is developed, how device user discover and binding devices to service based on data catalog. Thank you for your attention.